Hello! So it's getting to that time of year again where we dance around and listen to terrible music, cut down a tree and leave it to dry out in our living room while sprinkling decorations all over the house. Now when it comes to lights for said tree, there's literally millions of options available. Some of them can be rather unsafe by not complying with any safety standards. Some of them, as far as I'm concerned, are a little bit boring, and some of them have various pattern sequences they animate through and for some reason usually include a strobe mode. In this video, we're going to make and program our own lights for the tree that can run from a power bank, and I'll draw some inspiration from previous retro videos of mine. Modern day tree lights mainly use LEDs rather than incandescent light bulbs, and are quite often static, i.e. they don't flash, or often cycle between very simple patterns. Now I don't want such a boring setup, so instead I'm going to use LEDs that are individually controllable, meaning that each one can have a different colour and they come in many different forms. Here's a couple of LED strips. The main difference is the spacing between them, but what makes these different is that each LED on this strip actually contains a tiny little chip called the WS2812, which you can communicate with and in turn control the LEDs. When the chip is combined with LEDs and built into a package, they're often referred to as the WS2812. And I say LEDs because each of these tiny packages actually contains a red, green and blue LED inside, which you can see here in this video clip. I've used these strips before when building my crazy disco floppy disk cleaning machine, and they're very convenient to use. The way they work is you connect up your 5 volts and ground, then you send a special signal on the data connection. Each chip has a data in and a data out, each connected to the next. As the data comes into the first chip, it reads the first colour value, lights up the corresponding LEDs, and then only passes on the data after that. The next chip performs the same action, reading the first value for itself, and then passing along the rest down the chain, and so on. Because each chip only takes the first value it receives, each chip will receive a different value, and in turn you can program each one with a different colour. I don't want to use these kind of strips on the tree because let's face it, it would look kinda ugly. Instead, I'm going to use this chain of LEDs that I've used before when creating my fake FireFlies project. These contain the exact same chip, however, instead of being in a strip, they're attached to some enamel wires, making them more attractive, and you often see tree lights that look a bit like this. Now, when you buy these, they often come with a USB controller. I say USB, but it's more just using the USB for power. We don't want any of that, so I've cut it off, because I want to program these effects myself. And the effects I'd like to get working are static, i.e. not flashing in a choice of colours, fading through colours slowly, chasing LEDs, again with a choice of colours, even mixing some colours, and why not, let's add that stupid strobe mode as well. I'm planning on controlling all of this with a humble Arduino Nano and powering it from a USB power bank. First up, we'll need to connect the LED chain to the Arduino along with 2 buttons and a variable resistor that we can use later on. Now I've added a connector to my LED string to make them easier to manage, but we still need to do some soldering, so let's get that done. Some of you may have noticed that I started by removing and bypassing the diode on the back of the board. This diode prevents 5 volts from being sent back down the USB port if you power the Arduino from another 5 volt source. But since we're not going to do that, I've removed it, which gives us a small voltage boost. Now that it's all wired up, we need to take a look at programming it, a skill that doesn't come easy to everyone, but that's where this video's sponsor, Brilliant, comes in real handy. What I really like about Brilliant is you learn by doing it, with thousands of interactive lessons covering maths, programming, data analysis and AI. The courses that Brilliant provide help you improve your critical thinking skills by using an interactive problem-solving approach. You're not just memorising information, you're actually putting it into practice, which helps you understand it more clearly and in the end helps you become a better thinker. Brilliant allows you to build real knowledge in just minutes a day by breaking these courses down into small, manageable lessons, making completing them really easy. The growing number of programming courses that Brilliant have to offer is an excellent way to learn how to build real-world applications. If you're a complete beginner or need a refresher, you can start by learning the essentials from variables and loops to nesting and conditionals. And you can learn these essential principles in a completely no-code conceptual way. As you progress through these lessons, you'll develop your mind to think more like a programmer and start to begin writing more complex programs to build apps and even games. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/RobSmithDev, scan the QR code or follow the link in the video description. You'll also get 20% off an annual premium subscription. Thank you Brilliant for sponsoring this video. Okay, so the first thing we need to do is actually check they work properly. Now to actually control these we don't need to learn their actual communication specification, because if we install the fast LED library into the Arduino IDE, then this powerful library will take care of all of that for us, leaving us just the job of using it. The first few things I need to do are defining how many LEDs there are and then create an array for each of them to store their colour. Then I'll prepare the fast LED library by configuring it as a WS2812 set on pin 6 in RGB mode, with the colour correction to that of a typical pixel string. This slightly adjusts the hues of all the colours we set. Finally, I'll initialise the array to all white and tell the library we want to show it. So let's see that in action. You may be able to see here that I've stuck down the first 40-ish LEDs and left the rest coiled up. This will make it easier to see the effects. Now I'm uploading the program and, well, you may have noticed that that doesn't look quite right. It starts off white and then slowly starts looking very autumnal, with reds and yellows. The reason for this is just bad design. Like this, the LEDs are drawing 1.3 amps, and I've made sure I'm using a powered USB hub. The problem is, as we move further down the string, the voltage drop becomes higher and higher until not all of the LEDs get enough power to light, typically with the blue going and then the green. They're far too bright anyway, but if we use the set brightness command we can fix this. This is what it looks with the brightness set to 150, it's a little bit better. And this is 100. This is 75 and we're getting a little bit closer, but there's still some yellow in there. And finally, this is the brightness set to 50, which as you can see is now perfectly fine, and drawing a total of 800 milliamps. Now if we don't switch them all on at the same time, we probably don't need to set that brightness level, but we don't want them too bright anyway. Now, let's get on with the effects, and we're going to start with static colours. Firstly, you'll notice I've added some defines for the pins being used, and below that 2 variables that we can use to store the current mode. There's also a few variables to handle button input, but we'll come back to that in a minute. In the setup function, I've added some lines to configure these pins as inputs. I've also removed the code that we added to make all the LEDs white on startup, because we don't want that. Next up, I've added a function called handle buttons. This function can call the red button pressed and the blue button pressed, and it debounces the information to make sure that they're only called once. Now for testing, I've added some code to those to simply change the LEDs to red or blue accordingly. Finally, in the main loop, I've added a call to this button checking function. So let's try this out. Okay, so starting with them all off, now pressing the buttons you can see, the LEDs are changing to the colour of the button. So we have some basic controls set up. Let's implement the first item on my to-do list, the static colours, which I mentioned before. Now if you're not good with understanding colour values, then don't worry, because this library comes with a whole list of predefined colours, which you can see scrolling up on the screen right now, and as you can see, there's quite a lot of them. So, onwards to the code. The first thing I've changed is the red and blue button functions. I'll be using the red button to change the effect we're using, which for now just resets the sub effect. The blue button changes this sub effect mode from 0 to 19. Next, I added a few lines to the loop function to include a switch statement to call the function depending on which mode has been selected. And this is the static colour function I've created. The first 10 colours just go through a set of rainbow colours. The next 10 make every other LED the opposite of the one next to it. Finally, we call show to update the output. So let's see that. You can now see that the new program is being uploaded, and when complete, they all go back to red. Now pressing the blue button and we can cycle through the effects. There's some interesting combinations once we get past the 10th, and some of them look quite good. So that's the first effect. Let's have a look at the next one, colour fading. Well, there's a variety of different effects we can do here. To start this, I've added a second function call in the main loop. To make this work, I've modified the two button functions to allow the selection of these modes. I've also created a new function called run fade effects. This has a bunch of variables at the start, but you'll also notice that I'm reading the analog value from the variable resistor. This value will be between 0 and 1023, so I'm subtracting 512 to give it a range of minus 512 to 511. Now the first few effects call a special new function called RGB from hue. This function takes a number between 0 and 255 and returns a colour, somewhere within this wheel of a rainbow. The nice thing about this is it fully wraps around, meaning we can get any colour we need. Now the first effect just sets all of the LEDs to the same colour, with a small offset so they all change over time, and the speed of that change is controlled by the variable resistor. The second effect is like the first, only we slowly change that offset as we work through the LEDs, meaning we'll fade across them. The third effect is the same as the previous, but happens more quickly. Lastly, something totally different, this just fades between red and green. So let's program the Arduino and try this out. And once again, after uploading, we get red. I'm just resetting the variable resistor to the centre point before pressing this button to get to the second mode. And as you can see, we're now fading slowly through the colours of the rainbow. Turning the variable resistor allows us to change the speed of the effect and also reverse the direction as well. Moving on to the next effect. Now that's cool, we've got a lovely rainbow pattern moving along, and once again we can also adjust its speed. On to the third effect, and it's much like the second, but the colours are more closely packed together. Finally, moving on to the last effect with just red and green. An interesting effect, required a little bit more code but still looks cool, and again we can play with the speed. That's a real neat effect. So next I'm going to create some of the more traditional effects, chasing effects, which look like the LED is moving along the wire. These are actually quite easy to produce, so let's get on with the code. To start with, like before, I've added another function call to the main loop for mode 2. And I've updated the red and blue button function calls to support this new feature as well. Now onto the main event. The first few lines I've stolen from the previous effect, which is used to make the effect move at a specific speed controlled by the variable resistor. The next block I've stolen from the first effect to allow us to have a range of colours to chase. The last block, however, is new. This loops through all of the LEDs, but this line is really important. It gives us a number between 0 and 15 that is offset by the LED we're looking at, and the value of the counter from the start of the function. By using this, and when the number is 0, I can set the LED to be the first colour, and then at 8, set the LED to be the second colour. Finally, for the remaining LEDs we set them all to black or off. So let's take a look at that. Again, you can see the program uploading, and switching to the new effect, we can see that we have red LEDs chasing along the string, and I can control the speed again with the variable resistor, and even make them chase backwards. We can also change the colour, and pressing it enough times we get different pairs of colours too. That's a real nice effect. Okay, I know it's stupid and totally pointless, but as a nod to those cheap nasty effects you get with cheap Christmas tree lights, I'm going to add a strobe mode. It's actually very simple too. Just like before, we're adding code to the main loop and button functions, and for the strobe function, well, this is a little different. I've simplified the speed control at the start, and I thought I'd allow a simple colour selection too. The part at the bottom is the strobe, literally one line does it. I take the counter value, allowing it to go between 0 and 63, and if that number is less than 32, I set the LEDs to the selected colour, and if not, I turn them off. Just a quick warning, and it should kind of be obvious, but the next video will show stroboscopic effects. If this is a problem for you, I'll let you know when it's safe to look back. After uploading the code, once again we're back at the first effect. Going through them, we find our way to the strobe effect. Very slow to start with, and I'll change its colour. We can also use the variable resistor to control the speed, and it's working perfectly. Although I have no idea why you'd want that on your tree. It's now safe to look back at the screen because the strobing has stopped. Now, I could end the video here, but there's a couple more things I want to do. The first is to make it remember the selection when you power the Arduino off. So, let's add that in. The first change is to add the EEPROM library to the code. The ATmega328 has a small amount of EEPROM we can write to, and it's remembered when the device is powered down. In the setup function, I've added 2 extra lines to set the mode and submode variables from the EEPROM. And finally, I've updated the 2 button functions to write this whenever they're pressed. So let's test that out. Now this time when I upload the program, you'll notice that all of the LEDs have gone off. This is probably because the values we read from the EEPROM are probably not between 0 and 3, i.e. the effects we defined. They're probably either some random number or maybe 255. Not to worry however, pressing the red button and we're back to where we'd expect. Now let's choose a nice effect. Yes, that'll do. Then I'll unplug the power and plug it back in again. See, it remembered the setting. So the last thing I'm going to add is sound control, because, well, why not? Now, adding a microphone is really easy. You can use one of these modules that contains a tiny little amplifier on the back. It's easy to wire up. You simply connect 5 volts and ground, and then the output to, well, I'm going to choose A2, which is one of the analog pins. To demonstrate how easy it is to use, I've made a tiny program, and we can use the Arduino serial plotter to see what's happening. And I'll just show you that now. I'm uploading it and the lights have stopped animating. Now if I bring in the serial plotter, you can see this wobbly noise. This is just background static, and if I click my fingers, you'll see it can actually pick it up. But obviously that's not really any help. But I've done this kind of audio control before, right at the start of my YouTube journey by modifying this Pac-Man light. And we can't use that code exactly because it's interrupt driven, which will mess up the precise timings required for the LEDs. So instead, I'll do something a little bit easier. I also want to be able to disable the audio mode too, so I've added another button which makes the current wiring look more like this. It's not as complex as it looks. Now to accommodate all of this, there's some larger changes. Firstly, I've decided to use the FHT library because it's faster than the standard FFT. This will allow us to convert the audio into frequencies. The library you can download doesn't install properly into the Arduino IDE, so included with the source code for this, I've included a repackaged version, which installs properly. Code-wise, there's quite a few changes. I've added the FHT library to the code along with 2 defines to configure how we want to use it. I've also added 2 new defines, one for the audio mode button and one for the microphone pin. I've added some more variables which we'll use to monitor for bass beat sounds. And I've added a simple define that returns -1 or 1 depending on if a variable is positive or not. In the setup function, I'm initializing the moving average array with some values received from the microphone. That's not technically right, but it will do for what we need. In the main loop, I'm reading in the state of the new button, and if it's pressed, I'm going to run a special sample audio function. Now, sampling the audio, well, we want to grab 128 samples. Because of the way the analog read command is currently configured, this will work out to roughly a sample rate of 8,923 Hz. This can be changed, which I did with the Pac-Man lights, but for our purpose it's more than adequate. The sound is read into a special array provided by the FHT library, exactly as the documentation suggests, and calling the required functions after. Based on our sampling frequency and configuration, the sound frequencies that would be considered around the base area would be roughly around the first 5 indexes, so I add them together and divide by 5. The next step keeps a record of the last 32 base values and then computes an average. I use this to create a sort of threshold representing some sort of background noise level, which I can then use to detect a beat or a louder sound than usual. Lastly, this section at the bottom is just to keep the effects running if no beats are detected for a while. Now to make this work, I've had to modify each of the 4 effects as well, starting with the static colours. The only difference here is that when a beat is detected, we pretend that the blue button is pressed, which will cause the colour to change. The fade effect is just as easy, only this time every 8 bits the direction of the effect is changed, and every beat, the colour advances and jumps ahead or back by a large amount. I've configured the chasing effects much the same, only this time every 32 beats it changes colour. And finally, strobe. Well, there's really only one suitable option, strobe on detection of a beat. So let's try them all out, and to do this, I'm using the music from last year's Amiga Christmas game. This here is the new button for the sound mode, and this is the microphone module. Now I'm uploading the code, and I'll start the music. Right now though, you've probably noticed that nothing is happening, and the whole thing behaves exactly as before. And this is because our new white button isn't pressed. I personally think it's quite important to be able to disable this effect because it could be quite annoying and distracting. So switching it on, and we're straight into the strobe mode. Let's change that colour. Cool. Okay, let's switch modes. Yeah, that's working quite nicely, I like that. And another mode. Yeah, this works too. I think I kind of prefer the previous one. And lastly, the chasing effect. I think it's a little less obvious, maybe I could tweak the values a little bit, but you can kind of see them surge ahead every now and then. Not bad. Well, they're not bad, there's lots more I could do with these, and many more effects such as adding a timer so they switch off at night, but that shows you the basics. You can also rearrange these LED strings into a grid, turning them into a tiny little mini screen that you can display images on. After all, each LED can be treated as a single pixel. All the source code you've seen here will be available in the links in the video description, along with a list of required parts. I hope you found this interesting, thanks for watching, and I'll see you in the next one.